Hello! In this episode I'm going to be showing you how to unpack a texture pack and then use those textures within a Redshift material to create something like this. Now I'm using this simple object just to basically avoid UV unwrapping because that's going to be outside the scope of this video. However, if you've got an object which has clean UVs already, then feel free to use that. You should be able to apply the material to that and get the results that you're after. However, I'm just going to use a simple cube which is being subdivided, and I'll show you something to be aware of with that as well. So yeah, what I'm going to be covering is basically what the textures do from the texture pack and then how to use them. And I'm going to begin by breaking down the scene that we've got set up here, then going to the textures that we're going to be downloading, unpacking those, and then creating the material. So to begin with, what I have in the scene is a backdrop curtain with a very diffuse white material applied to it, and then I've got a dome light with a HDRI plugged into the texture for it, which will provide light information and an environment for the material to reflect. And then I've got a Redshift camera just placed in front, so I've got a position to render from. If you're unfamiliar with that setup which I've just gone over then, I've done a video on how to create a quick and simple scene setup, which I should have plugged in somewhere on this screen. Apart from that, we've got the cube which I mentioned earlier, which is basically a cube which has been subdivided. Now there's one thing to note with this, is that you need to ensure that you've got boundaries set on, and I'll show you why. Because if I create a default material, this is just a standard Cinema 4D one, not a Redshift one. I'm going to go into the luminance, go into checkerboard. Now you don't have to follow this, by the way, this is me just demonstrating the UVs. This won't be used in the final thing. So okay, so we've got a checkerboard which is a bit more easier on the eyes. And you can see just by default the UVs are quite nice. There's no distortion, everything's lined up quite nicely. Now if I go into subdivision surface and I set this back to its default settings, if I hit subdivide, you can see we've got this strange overlapping going on with the UVs. And that's because the subdivision surface has basically not preserved the UVs of the original object. So if I go into subdivide UVs, select boundary, it will retain the boundaries of the UVs of the cube that we're subdividing. So we keep the nice UVs. So that's just something to bear in mind if you're following along with the same objects that I'm using here. Okay, so that's that covered. Now the textures. I'm going to be using a texture pack from Polyhaven just because it's a public 3D asset library, so I know it's accessible to everyone. And the terms and conditions of usage are very flexible. You can use them commercially, so on and so forth. So yeah, there are other options out there, and so feel free to use those. You're not limited to using this, it's just that I'm using this because I know it's accessible to everyone. So I'm going to go into browse textures, type in cracked to get cracked concrete wall because that's one which I'm using. Now I'm using 4K resolution, however you can crank this up to 8K if you want. I'm assuming that means you get more detail, but I'm not entirely sure, to be honest. I've not checked. Anyway, I'm going to go into the zip file, and you should be presented with this window of contents here. Now I disabled the blend file because I'm not going to be using it in Blender. I turned off the GLTF because I'm not going to be using it in Game Engine or anything like that. And then all these other settings I think I've kept the same except for normal DX. Made sure that was disabled because we're not going to be using DirectX. Redshift and Cinema use OpenGL, so we're going to be using the OpenGL version of the normals. And then with all those checked, just hit download and then unzip the file. Okay, so now we're going to go to create Redshift materials standard, so we get a nice standard material. I'm going to apply that to the cube. I'm going to double click that material, so we're presented with the material node and the output. What I'm going to do is you can either click on create, add nodes, or you can just double click in this node editor to bring up this panel here. Select texture, click and drag a texture node. Now I think we've got 6 textures, Was it? Yeah. So I'm gonna duplicate this so we have 6 textures to work with. So let's start loading these in. Textures, we've got Ambient Occlusion, should be used for crevice detail. Then we've got Arm, which basically has Ambient Occlusion, Roughness and Metalness assigned to the RGB values. We'll also have Ambient Occlusion, I think we've got Roughness already anyway, but we don't have Metalness, so we'll keep it for that. Then we've got Diffusion, which is the main colour of the material. Then Displacement, which will be used to displace geometry and possibly as a bump map. Then we've got Normal GL, which will be used for the bump. We get lots of detail from it. And then Roughness. Yeah, I thought we had a Roughness map, which will be used to roughen up the reflections. Now a couple of these texture nodes seem to be black for some reason. The information is there, it's just an issue with the refresh. I think it's because I'm recording the screen at the same time, so if I duplicate it for some reason, that fixes the issue nice and quickly. So I'm just going to do that for these. Okay. So the first thing I'm going to do is assign the color spaces of these. Because by default, the texture node's color space is set to auto. Now, as far as I'm aware, when it comes to the auto setting in the color space, basically Redshift will assign a color space based on the naming convention of the texture that's plugged in. That's quite handy for the most part. However, if you're creating your own textures or using one of these textures unconventionally for a different parameter, then it may become an issue because it could be assigning the wrong color space without you being aware of it. So I'll show you what to use, like the manual setup, so then you know for the future what this should be, and then you don't have to rely on the auto settings. All this snapping's annoying. There we go. Okay, so for the diffusion or the base color, the thing which is going to be driving the main cover of the material, we want that to look how it looks. So we're going to set that to sRGB. Okay. Now the others, we're not using those for their visual aesthetics as such, we're using them for the data retained within that information. So we don't want these to be adjusted by the gamma, we want to make sure that these are as they were when we imported them. So what we want to do is make sure that these are all set to raw. So then we're getting the raw information and nothing's being altered behind the scenes without our knowledge. Okay, so what I'm going to do now is basically go through each of these textures one by one and plug them into the main material as we go. Because I did a recording of this earlier on and I went through them all one by one and then went through them again, plugging them in, and it got very confusing. So I'm going to start with the base color. I'm going to plug this straight into the direct output, get the render view open and just hit play. So here's the diffusion, the base color, and it does what it says on the tin pretty much. It's just, this is the base color, it's what you see. So this is quite a simple one. Plug this into the base color there. And ta-da, we've got the main color of the material. Now it doesn't have any of the other physical properties though, so we've still got this plasticky ball, but with a nice cracked wall texture. So it's kind of like a laminate material at the moment, I guess. Okay, so then the next one is Ambient Occlusion. Now this basically keeps black information where there is crevices within the texture. Now this was originally used as a way to kind of get around the reliance of using global illumination, because back in the day a lot of render engines relied, or a lot of rendering relied on CPUs rather than GPUs, and when it came to global illumination it was very intensive on the CPU, so render times took a long time, and if you didn't allow them enough time to render, you ended up with flickering and all sorts of artifacts within global illumination, and it can get horrible. I mean, there's one brief I did years ago which yeah, horrid. So thankfully tech has developed over time since then, so a lot of render engines use global illumination by default, and you wouldn't even really notice an issue with it. And a lot of rendering now is GPU based rather than CPU based. And on top of that, things like gaming engines have developed a lot since the early days. So yeah, ambient occlusion isn't really used as much as its original purpose is kind of faded over time. However, it still serves a use in that it retains information for crevices of a texture. So say in this example we're using a cracked concrete wall, we could use this material, or say this texture, as a mask for dirt details, for example. Or say if you're working with a metal material, these crevices could be used to retain rust as well as dirt and things like that. So it's a good mask to have, but its original purpose may still be useful if you're trying to avoid global illumination, but I think its original purpose is kind of no longer of use. Anyway, so with that in mind, I'm going to be using this as a mask for the base colour. So what I want to do is go into here and get a colour mix, I think. There we are. Okay, so what I'm going to do is use this as a mask. So I'm going to put this in a mix amount. And what I'm going to be mixing is the base colour and then a darker version of that to represent like dust and things like that. I'm not going to bother creating a bespoke material for that, so I'm just going to go colour correct. That'll do. Okay, just going to zoom out so we can see what's going on. Just going to unplug that for now. And unplug that for now, just so we're cleaning up what we're seeing here. So I'm going to plug this into the colour correct. And then in the colour correct, I'm going to set the level scale to 0.5, which will basically darken it as so. So we've got a darker version here, we've got the original here. Now in the colour mix, I'm just going to plug this straight into the output. I'm going to set input to black. Okay. Now this isn't looking like the original one, so I think we've got the input values the wrong way around. So I'm going to set this to black. Set this to white. There we go. Okay, now we're getting something close to what we were originally getting. So we want to make sure the bright one is in the input 2, because that's the brighter one. And then input 1 is where the crevices go, so we're going to put the darker version inside that. So then if we hit render now, this is what we get. It's not much different, but if we were to compare this to just the base diffusion, yeah, I mean, there's barely any difference, to be honest. You'll notice as we flick back and forth that it does get darker in those areas, so it does serve a purpose. Just how far you want to go with that is down to you. Okay, so I'm happy with that. That's doing its thing. So I'm going to plug this into the base colour. Then I can plug this back in as so. Just going to move these up a bit just so they're out of the way. Oh, this is getting messy. Okay, so just going to move those out of the way because we've done and dusted with those. The next one is this arm material, so I'm going to plug that straight into the output again, just so we can see what we're dealing with. Okay, so we've got this very sort of fluorescent material here. Now, basically ARM, this acronym ARM, is basically Ambient Occlusion, Roughness and Metalness, assigned to RGB. So Ambient Occlusion is in the red channel, Roughness is in the green channel, and Metalness is in the blue channel. So how do we get the information of those? what we do is search for a color splitter. With this, we can plug this into the input, and then each of these color channels, apart from the alpha, we can get the data for the ambient occlusion, roughness, and metalness. So here we've got the ambient occlusion. So what we can do is we can get the red channel of this and plug this into the mix amount. As far as I'm aware, it should be the same as what we had before. So actually, let's just double check. Okay, so we got this in. Yeah, let's stick with the raw values. Let this run for a little bit. Okay. And then we're going to get the red channel of this, plug it into where the ambient occlusion was. And then we're going to play it again. Now again, it was very subtle before, so we shouldn't see any difference really, because it should be the exact same. Yeah, they're identical, I think. Yeah. I thought there was a flicker at first, but no. All good. And then again, if we compare it with the diffuse, just so you can see something with a difference. Wait for that to go. There we go. Yeah. Okay. I just realised that this could be, I could sound like an absolute lunatic based on YouTube compression and stuff. You might not actually see a difference, but yeah, basically the ambient occlusion looked to be identical from this ARM material as the standalone one. So I'm going to move the standalone one out of the way because we can just use this ARM material for multiple parameters, which kind of saves us with a bit of real estate there. Okay, so we move that back up. We also get the roughness from this as well, from the green channel. So if I plug the, well, just plug the green one in directly, you can see this is what we're getting from it, which should match the roughness channel which we've got down here. So if I plug in the roughness channel here, I'm just going to save that, let this run for a bit. As you can see, well, I'm assuming YouTube compression isn't in the way, but it doesn't matter because they are identical. So you can see we're getting the roughness from this green channel, which we can plug straight into the reflection roughness of this, and it would do the exact same as if we plugged this into there. However, we don't need to. So we've got ambient occlusion and roughness over here because they're being controlled by this texture here. Now let's just see how things are looking. So far so good. Now breaking up some of the reflections on the surface of this. Now to cover roughness, because I kind of skimmed over that one, we knew what ambient occlusion did. Roughness on its own, just plug this back in. You can see we're getting black and white values. Now the black values will basically say to make the reflections crisp and clean, and then white values will say to roughen up or blur those reflections. Now I'll word that very carefully because it doesn't impact the intensity of those reflections. It just determines how crisp and detailed they look. So it roughens them up, hence the name roughness. So if I got a colour material and using the standard material that we've got going at the moment, to make sure this value is set to black, I'm going to plug this into the roughness. Play this back, and you can see we've got these shiny details here. Actually, I'm going to take the base colour off as well, just so we can see it better. You can see the reflection's really crisp and shiny because we've got a black colour plugged into the roughness. Now if I set this to fully white, you can see those reflections, it's still getting the light hitting it, same intensity, it's just being dispersed and scattered across the surface of the object. So those reflections are still there, they're just heavily blurred to the point of no longer being recognised. So what we can do is plug the colour back in, and then we can get the roughness from this, plug that back in, and we're back to where we were. Okay, so we've covered roughness. Get rid of that colour material. Move the roughness over here. Now the last one from this texture is the Metalness, which you get from the blue value. What we do for that, plug that into Metalness, and I'm not entirely sure what would have been in that, so let's have a look. I don't think there'd be any value in it. Yeah. Okay, so there's nothing there, which is probably why we didn't get a Metalness texture alongside all the other ones. So this is basically saying there's no Metalness, so we wouldn't even need to plug this in actually, because by default the Metalness is set to 0. But for the sake of habit, and we've got it there, keep it in place. Okay, so we've sorted that texture out. Now I've got two textures left. I've got displacement and normals. Now I'm going to cover displacement twice, because with displacement you can also create a bump map from it, because we're using the white and black values, and when it comes to actually using it as a displacement map, it can also be used to generate bump automatically within Redshift object settings. We'll cover that when we get to actually displacing. But for now, I'm gonna start using it as a bump map and then use it as displacement last. Okay, and then with normals, we're going to be using this as a bump map as well. However, this provides a lot more detail. I'll cover that in a second. So I'm going to start with the this displacement, use it as a bump map. So what we want to do is double click, search, bump map. Now for a standard bump map where we're using black and white values, what you want to do is plug this in, go into inputs texture and place it in the input. Now we want to make sure that this is set to height field. Okay, and then when we plug this into here, again I'm just going to unplug all those other parameters we had. So what we get is this bumpy detail on the material. Now this is purely a shading trick, it's not actually altered the geometry in any way. However, when we get to displacement, you'll know that that will be altering the geometry. So that's a key distinction between the bump map and displacement. Now this is the cheapest method of creating bumpy details, and it's quite useful because it's very efficient when it comes to rendering and stuff. However, it doesn't yield as much detail as a normal map, which we'll get to in a moment. All you need to really know is that the white values in this texture will raise the surface outwards based on the normals of the polygons, and the black points of this texture will basically not affect the bump of this material. So white pushes it outwards, black basically doesn't affect the bump. So that's how you're getting these bumpy surfaces here. Now when it comes to the normals, we use a bump map for that. However, once we plug this in, we need to change the input type from height field to tangent space normal. So whenever it comes to normals, we use tangent space normal. Now when we plug this in, I'm just going to save that for now, and then we'll do a comparison. You can see we get a lot more detail. Now, I'd say normals would be the best way to generate as much high quality bump as possible without displacing the geometry. Now how this differs from bump is, as you can see, the main thing is difference in level of quality, but the normals basically use colour values to determine the direction of the bumps. So with this black and white displacement, it's just saying white pushes outwards, black doesn't do anything, or depending on the mapping, black could push inwards. However, with this, it's saying, okay, create these deformations based on various angles, which basically yields a much more detailed result, because you can get more detailed crevices put in place and deformations a lot cleaner. Now I could go into saying that it does impact how the light hits the surface and stuff like that, but I'm not sure if that's accurately correct from a technical standpoint. So I'm going to avoid saying that, but that's how I've kind of kept it in mind over the years. But yeah, so basically it's just a more detailed bump. That's the main point of it all. Okay, so one thing you may have noticed is that when I plugged in the normals, it overridden the bump that we had in place here, which is pretty annoying because if you wanted both of them, you're kind of stuck. So in order to overcome that, what you need to do is go into here, type in bump blender. So what we're going to do is drag this to anywhere within this box. Inputs, base input. Okay, so we've got the black and white displacement, which we're using as a bump for now, in the base input. Then get the normals, drag this on, bump input for that in layer 0, set the blend weight to 1. Now with these settings, basically the normals are just completely overwriting the previous bump that we got there, which is like what we had here, where it's just completely overridden it. However, if you select additive mode, it will add those two bumps together. So you should get this. So I'm just comparing them. Okay, so this is the result of both those bumps blended together, which gives you a very detailed level of bump. So here's just the normals. Here's black and white. Actually, it should go in the other way around. So here's the displacement being used as a bump. You're getting some details. Here's the normals. Getting a lot more detail. Here's both of them put together. Incredible amount of detail. So it's good using them in combination. However, it may be a bit much because they are both adding to each other. So you may need to go into the height scales of each of them and maybe halve them so it's just not as bumpy. But it's up to you. If you want it to be more bumpy, you can increase those height scale values. It's up to you. Anyway, so I'm going to unplug all that and just use the normals, because we're going to be using this displacement as a displacement map, and within that it will generate bump automatically as well. So we'll get that additional detail without having to use this bump channel. Okay, so how we do that is double click, search displacement. As you can see, the displacement blender as well if you ever needed to merge displacements. Now I'm going to plug this into here, and we plug it into text map, which is basically the same as input. I don't know why it is renamed, but there you go. And height field is fine because we're dealing with black and white values. I'm going to keep all the other settings the same for now. I'm going to drag this into the displacement of the output, not the standard material, because this isn't affecting the material, it's actually affecting the geometry of the object. So by default, actually I'm going to unplug that bump for now. So we just got that basic grey sphere again, but being displaced with this displacement. If I play this back, you can see, you know, there's not really much there. You know, it's quite underwhelming compared to the bump that we had before. Now that's because now that we're altering geometry, what we need to do is ensure that under render tags, we have an RS object tag attached to the object that we're going to be displacing. Then under the geometry, go to override, and then enable displacement here. Now you can add more tessellation if you want, you know, if you wanted more deformation, which you might do. I've got quite a lot of polygons anyway, but I guess there's no harm in using that as well. So now we've got displacement on. I'm going to play this back, and you can see we're getting bumps again, and it's not too noticeable, but the actual contours of this shape have adjusted as well. So I'm going to amplify those in a moment so we can see what it's actually doing, because it's quite hard to tell with the texture that we're using. Now the first thing to note is that we have enable auto bump mapping ticked on. Now that was what I was referring to before when I said it generates bump as well through displacement. So if I disable this, play it back again, you can see the bump detail's gone. However, we still retain the deformations from the displacement. So this is what the displacement's doing on its own, without the bump being applied as well. So say we wanted to exaggerate this, go into the material, go to the displacement, and say we set the scale to 10. Okay, I'm going to save what we had before, play this back, and you can see we've just gone back to a smooth sphere. The reason for that is that basically in the Redshift object tag, we've got these values here, maximum displacement and displacement scale. Now the maximum displacement is basically acting like a clamp, so it's saying if it exceeds this value, then we just cut it off. It can't go any further than that. So basically what we have here is a displacement pressed up against that threshold, so everything just looks flat basically, because all the geometry is just pushed out and hit that threshold, so we've lost all that detail. However, if I increase this to say 10 to compensate, so now it can extend as far as the value we assigned in displacement, we end up with this ball of mush, this swollen mess. Now this obviously isn't, or probably not what you're after, but if you ever get the displacement values clamped, this will be why. So I'm going to set these back to the default settings so we don't end up with this swampy mess. And then, yeah, so we're getting little bits of bumpiness in there. We could push it a little bit, maybe. Say, again, I need to update the maximum displacement. I'm going to set this to 3. Actually, I could keep this to 10. That way I have the flexibility to increase it and decrease it as I like. So yeah, I think this is quite good. It's more than, probably more than what the material needed, but it's, you know, adding a bit of shape to the contour, and especially since we're using a sphere, you know, it helps. So yeah, that's pretty much it. We're going to just plug everything back in. So we got the base color from the ambient, occlusion and diffusion. Then we've got the green value of this arm material, which would be the roughness. We've got the blue material, the blue channel from this arm material for the metalness, which is actually empty, but we'll plug it in anyway. And then we've got the normals with the tangent space normals in the bump map, plugged into the bump map. And then here we've got the displacement plugged in into a displacement node, which we've amplified here, which we can do because we increased the maximum displacement. And I'm going to enable auto bump mapping. So then when we render it out, we get this. Okay, yeah, I don't like that displacement. I'm going to dial that back down. So we get this. That's basically how to reconstruct that material we worked with. Thinking about it, I think I'd actually rather have the displacement in its own bump channel, because then I can control the bump without having to be constrained to this checkbox control and everything. But anyway, yeah, I think in hindsight, better turning that off. And then again, I'm just going to do this quickly. Just do what we did before. I'm just going to plug this in. I don't think it matters which order we plug these in, because we're going to be doing an additive transform. But just before I end the video, because it's getting to me, I'm going to do is hit blend weight 1, additive mode, make sure this is set to height field, everything is good to go. Cool. Doesn't look much different to what we had before. Well, actually it does a little bit, there's a slight difference. Anyway, by doing this, I'm able to control the height of the bump map separately from the displacement, which I think is a lot better. So yeah, there you go, there's a quick tip at the end. Yeah, sorry for the cut. Yeah, just got a bit noisy outside. Anyway, we've reached the end of the video anyway, so I hope this has worked out for you. If you have any questions, leave them in the comments below. Other than that, hope you have a great day and hope to see you in the next one.